Hello everyone. Have you trained a machine learning model, deployed it to production, and walked away thinking you were done? Unfortunately, life is never that simple. In this pro tip, we'll discuss how the performance of machine learning models can drift over time and needs to be monitored in production. For instance, if we built a model in the early 2000s to generate yearly blockbuster video revenue and never updated it, the predictions today would probably be more than a little off. Exogenous factors and technology changes cause models to no longer represent the current state of the world. This is a concept called model drift. The reliance on just-in-time inventory and the growing global economy allows small events to ripple through supply chains, making model drift more likely. We have seen these effects in multiple sectors affecting our daily lives. Multiple types of model drift can occur, such as data drift, concept drift, and upstream changes. Let's discuss each of these. Data drift occurs when the properties of the input data change. Poor sampling technique, change in product inventory, or non-stationary data that evolves over time, like salary ranges, are examples of data drift. Concept drift occurs when the relationship of the input features and the target features changes. For instance, changes in medical technology which can affect predictions of life expectancy, or changes in the average age of the application's user base that affect utilization rate. Upstream changes describe when a change in the data pipeline affects the input features. An example of this is a change in the data ingestion from daily to hourly. There are many techniques to check for model drift. For data drift, shifts in summary statistics like the mean, median, and standard deviation may alert you to changes. Statistical tests such as the student t-test and the Kolmogorov-Smirnov test, or feature importance metrics like LIME or SHAP, can also be helpful. For concept drift, we need to identify changes to the decision boundary. By measuring the accuracy of the model over time, we are lured to a gradual or sudden decrease. We can also monitor the target variable to see if the class balance changes. Finally, for upstream changes, you can utilize tools such as Great Expectations, which monitor type, frequency, and granularity of incoming data. Now that we have identified model drift, we can take appropriate actions. We'll cover that in a future pro tip. Drop into the comments and let us know how you dealt with or encountered model drift, or give us ideas for future pro tips. Thanks for watching.